OTDR. Anybody have a clue what that means? It's not optical time domain reflectometer. Okay. Not that one. This is operational testing of DNS. And I'm going to talk a little bit about the test bed that we've been running and some of the focuses, and then look at infrastructure pieces and why they're... I should charge my battery. If it was my battery, I would charge it. There we go. And now the microphones aren't working. Okay. This is actually to check and make sure that you're still awake and you're still inside this dark, cavernous room instead of outside. So anyway, the sad part is that this won't take 20 minutes, so you might actually get out early. So page up and page down. That would be page down. Okay, though they have the same 3 letters to start them, IPv4 and IPv6 are not the same protocol, if you hadn't noticed that. They are different enough that you actually have to look at how you're going to deploy them. Most people that have experienced v6 look at this and they say, we really don't want to mingle this with our v4 stuff. It gets confusing. The most obvious thing is that v6 has larger addresses. From an operations and from an end user perspective, this, I don't know of too many people except for Andrew, who's just yawning and falling asleep back there, who can remember mnemonically an IPv6 address. They're just too large. He hates it too, of course. Right? So for people, in v4, most people can remember a 32-bit address. If I was to ask you what the IP address of one of your router interfaces was, you could probably spit back the, 192.168.13.3, right? You can remember that. IP was designed around the fact that you would have address literals. So a friend of mine came up with this phrase a couple of years ago that said, there are no urgent DNS problems. The net will continue to run without the DNS. In the case of IPv6, address literals become problematic. You can't remember them, so you need some mechanism for doing name to address resolution to work all the time. Criticality of the DNS goes up. Packet size changes between v4 and v6, and we're going to come back to that. That actually is a real issue. Now, the DNS protocol itself presumes IPv4 in a lot of its design. There's this thing called the priming query. When you don't have any information at all, you are trying to get a name resolution, you ask the question, and any of the root servers are supposed to respond, and you have to get all that information back, or you send all that information in a single unfragmented UDP packet. Unfragmented UDP packets between v4 and v6 are different sizes. Now in IPv4, in general, it seems to be much, much harder to do other than minor incremental changes to IPv4 at this point. It's really tough. The installed base is huge. So this is actually, I'm borrowing this from a guy named Tony Lee, which talked about, as far as routing infrastructure, is rebuilding the airplane in flight as far as the evolution of BGP. This is not really sound software engineering practice. Sometimes you have to do this. So the question we ask ourselves, at least as far as IPv6 and in the case of DNS, is the code stable? And actually, I invert those. Is the spec stable? I talked with Tony Hain, and even though there's still a fair amount of discussion on the protocol development lists on the IETF, the spec is mostly stable, mostly. Only a couple of reasonable sets of changes, supposedly. The code that implements that, is that stable? Well, the DNS implementers that I've talked to have made what is they've bent over backwards to accommodate the changes in the DNS support for IPv6 as the IETF has had difficulty making up its mind. But they're pretty good. They've done pretty well at that. Then are there going to be infrastructure issues? We've got stuff that's out here that supposedly works. We've got operating systems that have v6. We've got DNS stuff in the DNS. Is this going to work? It depends on the infrastructure stuff. So a couple of years ago, actually it's more than a couple of years ago, a number of the root server operators built a closed test bed. We looked at what the IETF was doing and we said, IP version 6, DNS security, internationalization. God help us if we're told to turn all this stuff on and we don't know what it's going to do. So OTDR was created to test new resource record types, test DNS transport, and some of these other things which I'm not going to talk about a lot today. After a couple of years of closed operation, I came around and briefly talked about the fact that we were opening this up for people who wanted to test. As of this point in time, we have a reasonably large number of TLDs participating. These are folks that will take registrations for IPv6 for those particular sets of TLDs, and the root will run this. You can find some more information at that particular URL. Things that we have discovered thus far. IPv6 resource records can be added to nearly all the deployed DNS nodes as far as the code bases goes. You can't put them in DJB DNS, and Dan would say, sorry. I was told right before lunch that Ultra does have the support, but you have to ask nicely. So you can get it in Ultra, is what they tell me. I've not tested it or seen it done. IPv6 transit triggers infrastructure issues as you try and cross between v4 and v6. And we'll talk about that in another couple of slides. Now, people that are doing registrations, we had some ongoing issues with the Japanese. The Japanese would dearly love to be able to have ICANN register a Quad A record for JP. And ICANN is waffling, looking for guidance. Some of this is that the registry code doesn't have all the capability and support for that stuff yet. They've known about it for a while, but they're trying to get there still. Now, most modern OSs have IPv6 stacks that mostly work. The difficulty is that, at least in Red Hat's case, they can't make up their mind about how they want to support it. Moving targets. If you're doing infrastructure, DNS in particular deals with the idea of a minimum unfragmented UDP packet size. If you're running just v4, we know what that is. If you're running just v6, you know what that is. If you're running dual stack, which one do you pick? That's the question. The bigger one. The right one. The right one. I'm not picking him. So it becomes, people don't really know. I mean, if it was me, and what I've actually seen tend to work most of the time, is that you go to the lowest or the smallest common denominator here, which tends to fragment unnecessarily the IPv6 stuff if you're trying to put stuff in 512-byte packets. There's a thing called enhanced DNS 0 coming out of the DNS working group. That's really required in the servers if you're going to support IPv6 because the packet sizes can get quite large. They can be large enough, particularly if you start adding some of the other capability, where you get UDP fragmentation on 4K packets and larger. And sometimes you even push this into TCP rollover where UDP doesn't work. The amount of data coming back, you ask a simple question, the amount of data coming back is so large that you end up having to retransmit with TCP. In this case, the DNS traffic profile starts to look an awful lot like streaming content. You send a couple of queries and you get a whole bunch of junk back. Then IPv6 has this other I hesitate to call it a feature. One of the architectural design choices is that you get a block of addresses from all of your upstreams. And so instead of having a single address on my interface, I'm going to have 3, 6, 15 IP addresses on the interface. Which one do you pick? Which one does your application pick? And so source address selection for applications is still relatively up in the air. Now, as far as infrastructure goes, these are bad things. Equipment vendors, in general, work on razor-thin margins. And for equipment vendors who are working on razor-thin margins, I'm going to go back to some ancient history and I talk about gate count. The fewer transistors they have to put on, the cheaper they can make it. The fewer functions they have to implement, the quicker to market. And so you see a lot of people who are going to go for the 80% rule. If they can solve 80% of the problem, they can support IP packets, NAT, and run everything through port 80. They'll drop support for pretty much everything else. So they think locally. These are local optimizations, which, in the case of a v6 world, really seriously impact things. So we see things IPv4 assumptions hard-coded in firewalls. Now, I'm not going to pick on Cisco, but the PIX blows chunks. Anything over 512, and it just drops it on the floor. So UDP fragmentation doesn't work even in a v4 arena. So I said, I'm not going to pick on Cisco because I don't think they actually built that one from scratch themselves. There are these things in a hotel. They will have things like DNS proxies, which don't necessarily understand some of the new resource record types. Suzanne touched a little bit on some of the load balancers and some of the presumptions they make. Some of the earlier layer 2 fabrics that you saw at exchange points had some interesting issues dealing with the size, the assumptions on MAC tables, the CAM entries, and also buffering issues. All of those things tend to be problematic from infrastructure. So if you're looking to have good v6 support, you're not going to find the problems in the end systems, and you're not going to find the problems in the applications. It's going to be in that last 100 meters, what people get by to connect to your infrastructure. From a DNS perspective, there's this thing called tree consistency. The IAB has come out and says the DNS is a singly rooted tree, except I now have 2 distinctly different protocols. To maintain the illusion of a singly rooted tree, I have to run dual stack. And dual stack has more infrastructure issues than I care to deal with. Rock in a hard place. IPv6 also has this other interesting thing called mapped addresses. You can take your IPv4 address, slap 2 colons and a couple of Fs on the front of it, and it will look like a v6 address. Some operating systems will treat it as a v6 address. Some of them will treat it as a v4 address. FreeBSD, between minor revisions, changes its interpretation of that. It's kind of dicey. Don't put them in the DNS. Same with link local addresses. So we've tested some interoperability. This isn't always v6. Close your eyes. If anybody that's done anything with DNSSEC, don't look at the first bullet. Supported resource record behavior. Sometimes you'll see support for some things and not the others. The A6 records support has and has not been there. Bit strings is gone, which is a shame. You'll find that at least if you're running DNS servers, that you really need to look at who are your slave servers. You need to make sure that you're running consistent code so that the data stays the same. And then if, like Aave, you're going to put a caching server in every one of your POPs that all of your clients are going to use, they may be caching the wrong data because they're not up to speed. So the winner here is that for IPv6, and particularly with the context of the DNS, most of the issues appear to be known. We've been hammering on this for a little over half a decade. Specifications are mostly stable. And at least the reference implementation of bind, it's becoming fast enough to be actually useful. On the political side, there is a draft recommendation that is being circulated for the powers that be to formally augment the routes with IPv6 transport, i.e., eventually we will see the hints file changing and having IPv6 records show up in there. And many of the TLDs are already running IPv6 enabled servers. But there's this gap. This is probably in poor taste given the train accidents in the London Underground. But there's still a pretty big gap here. Registration software, if people want to do this, the registrars cannot support it generally, even though they've had it on their development profile for a while. The DNS evolution has embraced and accommodated IPv6, so if you want bind to do v6, it's a no-brainer. It'll do it. It's been capable of doing most of this for years. However, the deployed infrastructure is not friendly to IPv6. And what you'll find is that for a variety of reasons, you're either going to be doing IPv4 in the fast path, and you have people paying really good money for this, and then some academic is going to come up and say, I want v6. And they're going to say, v6, slow path, dual stack, it's going to impact my production stuff. I really need to do this on a separate box. That's more CapEx and more OpEx. Right? So in the case of people who are wanting to do DNS and to do it over IPv6, the availability of the service will be sporadic. It will appear that way. This is generally because of local optimizations for IP version 4, generally in the last 100 meters. And so as you contemplate v6, you got to go look at the entire path to make sure that those kinds of landmines are eradicated if you want to satisfy the people who want v6. If you don't care about v6, you shouldn't have been paying attention. You should have been out drinking or something. So, questions? The airport closes at 3 o'clock. No. No questions? No comments? Have I told you lies? Okay, Barry?
All right, thank you.